All right, morning everyone. So yeah, I'll be talking about FABDEM today, as using global flood applications. Also like to have a shout out to Peter Ure, who's kind of my partner in crime, he's partner in crime from FABDEM. Just before I kick off, I'd like to say thanks to GFP for helping out with the ECR event last night. It was brilliant. A lot of new people met each other, and thanks a lot for that. So I'm going to play a bit of a risky game here and do some audience participation on the last day of the conference. So hands up who uses digital elevation models in their work. Okay, pretty much everyone. For you who don't, do you use like population data sets, travel time data sets? Do you use fitness apps? Hands up, yeah, all those sort of things. Again, they all have elevation models in them. And who's heard of FABDEM before today? Hands up. Oh, that's good. The relentless social media campaign has paid off. Cool. So some of you might recognise this as being Yorkshire. So this is where we are in the GFP today. Right. So outline the presentation. Well, a lot of you know what FABDEM is, so I'll kind of go over that quite quickly. Latest developments, so these are kind of hot off the press, things that have been unpublished and kind of what's in the pipeline, and flood applications as well. So when I was initially doing the presentation, I was kind of doing a load of model results, etc. But then I thought, hang on a second, we need to translate what this actually means to users. So, you know, just on the start of the network, whoever, what these developments could mean and what might be possible now. So we'll kind of we'll go from the start sort of thing. So basically, global digital elevation models are nominally they measure the surface. So you're going to have forests and buildings within them, which is not conducive to flood models, basically. So the difference in what a digital surface model might look like is on the left-hand side, and digital terrain is on the right-hand side. Now the massive problem is, and we're looking at global applications here mostly, or looking in data scarce areas. There's no global digital terrain model, basically. So a few years ago, I kind of totted up and estimated the land area, which is covered by LiDAR, which is kind of like the reference high quality stuff like you might have in the UK or more developed areas. And at that time, it was way less than 1%, actually about the same sort of likelihood as having triplets. So and having which is a bit crazy, but it's way bigger now. It's probably nearer like 1%, but still it's a tiny proportion of the world. And up until FABDEM, probably the best and closest thing to digital terrain model at global scale was Merit DEM, and that removed trees from SRTM, but no buildings. So kind of a few years ago, something called Copernicus DEM was released. So this is based on TandemX, which some presenters on day one kind of touched on. TandemX is a great product, but unfortunately, it's you can only have it for a small area for research purposes. So the Copernicus group, they kind of they basically created a 30-meter DEM and did a lot of cleaning of the product. And there's been a few studies kind of comparing SRTM, ASTERs, and the other global DEMs, and they kind of found Copernicus DEM was like the gold standard, the new best global DEM out there. So basically, this created a big opportunity, really. So now we've got a better baseline product than SRTM. Yeah, I know a lot of people like SRTM here, which is fine, but so yeah, basically an opportunity not to create a new product that removes trees from Copernicus, and importantly to remove buildings as well, because that was a major problem with digital terrain models. So quickly go over the workflow. Essentially, like everyone does these days, we put machine learning to the problem. So essentially what we needed is to get predictor data sets to predict the height of trees and buildings. So we spool all the data sets that are out there. Got like urban footprints, population, canopy heights, all that sort of stuff. Like all global data sets, these ones are also imperfect, so we had to kind of put some image filters over them, etc., to just try to kind of tease out those relationships. We also needed predictor data, reference data sets. So LiDAR, like I don't know if I'm LiDAR, but it's not globally available. So we had to really get them from all these a wide range of countries. And the real key thing here is to get a wide range of urban and climatic zones. There's no good training a global model on LiDAR from Leeds, for instance. You need as many areas as you can as possible. So we managed to get some LiDAR from like South Africa and Brazil and quite a wide range. Of course, it's not perfect and we easily criticize that, but it's kind of the best you can do, really. Step 2 is the actual kind of the meat in the sandwich. So we did the forest correction and the urban correction. So on these images here, so the dotted line is Copernicus DEM, for instance, and our corrected services, the solid lines. Now, sometimes the model's not perfect. It might over and under correct. So on this right-hand image, you can see the dark black lines. So we need to do a lot of post-processing. So we had the sort of the images like the filters like adaptive filters, and also used a whole bunch of other ones. And this is just to kind of correct those sort of where the algorithm wasn't quite perfect. So what does this mean? So images here of Paris. So the top is the original Copernicus DEM and FABDEM. As you visually, Copernicus kind of looks nicely because it has that roughness. You can kind of see where the buildings and features are. But for flood models, we want this kind of smoother surface down the bottom. And this sort of error stats is what we compared against LiDAR. It's decent sort of correction. This is an example from Germany, which I think is quite nice. So in this top image, we have a river. You can kind of see going through there, and then you can see the sort of yellowish dots, and that's trees on the embankment. That's a big problem for flood models because basically it didn't really flood. However, FABDEM kind of did a pretty good job of removing these trees, so it's a lot more realistic. A bunch of images here. So Merit on the left-hand side is kind of the best perhaps before FABDEM. FABDEM in the middle and LiDAR on the right, so that's kind of your benchmark. So you want your digital elevation model to look as close to the right-hand image as possible. So like visually, it looks pretty similar. Saying this is St. Louis in USA. Again, similar sort of story. What about in more data scarce areas? So this is FABDEM compared to Copernicus and the Mekong Delta in the top 2 images. We can see like where the correction has really made quite a big difference. We compare it to Merit in the bottom left, and NASA DEM is on the right hand side, which you can see is still a bit noisy. You still see those striking sort of artifacts. So what makes FABDEM unique? So it's the first global DEM to remove both buildings and forests. It has global coverage. Well, when I say global, it goes up to 80 degrees, which basically the vast majority of people live. So it's the first terrain map at 30-meter resolution. So that's quite a big step. And it uses a nice wide range of reference data. More details, so it's a big old data set, 460 gigabytes. New versions are a bit less than that. 19,000 tiles, 1 by 1 degree tiles. Yeah, and so where can you actually get this? That's important, of course. So if anyone's, I apologize if anyone's got to access this through Databricks because it is painfully slow. But that's kind of the best way if you want it for research applications. There is a faster BitTorrent available, and you can also get it on Google Earth Engine. I had nothing to do with the Google Earth Engine thing, but it is available on there. For non-research applications, you have to contact FABDEM. Ollie Wings, FABDEM representative here. So yeah, you can contact them. But they're usually pretty open. I'm not really privy how much they charge and stuff, but the humanitarian things, I think they're pretty kind of open. Like limitations. So there's some important limitations with FABDEM. It does not include Armenia and Azerbaijan. This is basically because this was not in the original Copernicus DEM, because they were having conflict at the time, basically. So didn't want to release that. So the next big question is the post-processing suitable for all landscapes? Now, being developed by FABDEM and myself, like flood modelers, so we focus a lot on floodplains, and we think we've done a pretty good job there. But if you're looking at landslides and whatnot, kind of not really sure if the post-processing is good for that. Currently no watermarks or compatible hydrography, so there might be some news on that, and I'll tease you about a bit later. Right, latest development. So we released it whenever it was, a few months ago, and then of course you have people come to you and like, oh, this looks a bit weird. Yeah, some people in Brazil reported this issue in forested tiles. Basically, if the tiles are completely covered by forests, we were having a buffer which uses the uncorrected DM, and you kind of see these. Yeah, this is what that uncorrected DM looked like, and what that meant was when we're filling the valleys, it was filling up way too much. It was taking these higher heights of the uncorrected buffer and filling them up, which was not good. And you can see, so FABDEM version 1, this is like the one on data grid currently, we have kind of these tile edges, you can see. But on FABDEM version 1.1, that was fixed. So that's kind of one important development. So if you're working in like the Amazon or Congo, you might see these sort of things, but pretty much everywhere else you'll be fine. The next development, so we kind of just finished that, and then we're like, oh, it's a few tiles in the northern latitudes that are a bit weird. So we kind of thought, okay, let's have a look at these. And it turns out that Copernicus has updated their baseline DM. So we thought, okay, we might as well rerun the whole algorithms again. So all these squares here, all the tiles that the Copernicus people have changed since the one that we used. So we've rerun the algorithm. And created version 1.2. Mostly this doesn't make a lot of difference. So this tile here is barely a little bit different in the corner. So this is the difference map between version 1.2 and 1.0. But for some tiles, some pretty huge things happen. So yeah, kind of just be aware of that. So as the timeline, so 1.1 never actually got released. It's going to be superseded by 1.2, but we're going to release 1.2 probably October, well, next month. And then FABDEM 2, so that's kind of going to be something that's happening in 2023. So the DMs are constantly evolving, the data sets you can train machine learning with, it's constantly evolving area. So we're very much working on this. I kind of naively thought when I created this, I could just leave it off the shelf and whatnot, but that is definitely not the case. Yeah, anyway, so this is really hot off the press. I got this just past midnight last night from a colleague at Oxford University, Michael Vortman. So he works on the Evil project, which currently I'm on and pays my bills. So he's created a FABDEM-based hydrography called GRIT. So this is a kind of first global 30-meter hydrography. And the really neat thing with this is he's kind of managed to solve the holy grail of having bifurcating channels in hydrography, which is really, really exciting. So here's a map of the Mekong. Yeah, so he uses a lot of like OpenStreetMap, Google watermarks and whatnot. He's preparing a paper for this at the minute. I know a bit about it, so please do ask me, but yeah, contact Michael Vortman at the University of Oxford if you have any more questions. He was supposed to be here today, but he couldn't be, so I'm just doing butchering his work basically through him. But it's exciting. That's the headline. And that's probably the biggest question I get asked. Oh, when's the hydrography coming out? And oh, are you doing one? I was like, absolutely not. Hydrographies are an absolute nightmare to do. So I'm going to let someone else do that. So how am I doing the time? Okay, not too bad. Flood applications. So I'm just going to show you a few flood applications with the Bristol FABDEM global model. I mean, of course, this could relate to yours as well. So this is for Vietnam. So this particular image is using SRTM, the very kind of simple FABDEM one to begin with. So because it has a lot of artifacts, you've got the trees and the buildings, it often not flood. This is using Merit. So you can see kind of the difference straight away there. And this is using FABDEM. So FABDEM, you can really see these floodplain features quite a lot more. And this is all of the images on one sort of slide. So a nice bit of visualization there. Oh, sorry. Here's a nice nice video. So again, we want to be like our right hand side here. This is LiDAR. This is in Australia somewhere. So yeah, FABDEM does pretty good job. Germany example, same sort of scenario as before. So version 2 of Merit, version 3. Now I think where the interesting bits with FABDEM comes in, and at this sort of resolution, is we can do a lot better job of doing behavioral modeling now. So like this is in Germany, for instance, but I've had some students work on Lagos, and I believe some people in here worked on Addis Ababa and Lusaka, and I think we're getting to a stage now where we can do some kind of sensible, semi-sensible previewal estimations and like urban modeling. Of course, some people might not say it's good enough. That's fine, and obviously you want to use LiDAR if you can, but I think it's getting to a stage now where we could perhaps trust these models a bit more. I probably don't have no, I don't have time for this. This is another Vietnam example. I guess this one image here is nice. So on this image here, this is land parcels basically in the survey that we used, and these orange ones are people reported not flooded, and the purple and yellow ones they did report flooding. So you can really see that sort of like nice kind of area down there with all the not flooded ones. It really kind of get that flood boundary quite nicely. And as we were discussing the flood severity index discussion yesterday, like that's a real key thing with flooding, that sort of boundary. Definitely not have time to explain that. Yeah, so what does FABDEM offer? And why is it interesting? So I think someone from the Start Network yesterday saying doing these more frequent floods is really difficult, and global flooding hands are doing that currently. So I would say from what we've kind of looked at, modeling these 5 to 20 year events are a lot better with FABDEM. And as I mentioned, pluvial modeling, urban modeling, we're getting to a much sort of better stage there. I would say if you're going to do absolutely massive model, massive floods, you know, Merit probably does a good job for you still, but these sort of smaller events, yeah, I'd say FABDEM is a good sort of way forward. I'm just going to leave on this slide. So yeah, Evo flood. This is new NERC massive project looking at evolution of flood hazards globally. So it's got a lot of geomorphologists, climate people, population people, and essentially we're determining which is the most significant factor. So I'm a small part of that cog. Solomon is not here today. Okay, so Solomon's also part of it. So yeah, please get in contact if you have more questions. Right, am I okay for time? Good, hopefully some questions. Sorry, I'll whiz through that.
Laurence, yes, definitely. I myself can confirm, yes, started looking at that. It's a fantastic product, and I think it will be, I would say, a standard, at least in the flood modeling community for quite a while. So I'm sure there are questions, many. So let's start here.
Yeah, I thought I'd like, yeah, the questions are more useful to me talking about. Yeah.
I'll say thank you for us developing everybody in the community appreciates getting another option, but with that the challenge then becomes as you've got more options as which one is the best for an application. So you're focusing on flood, which is good.
Yeah.
For everybody here, obviously.
Yeah.
So the question is when you're trying to really prove to yourself how good this isn't an area you've got no real knowledge on. Are you using global statistics, or are you looking at spatial fidelity of the channel? And the question really is with the point that we can be seduced by nice visualization. Water's flowing along. It looks pretty good.
Yeah.
But that isn't necessarily where the water's going to go, really.
Yeah.
And then a related question is, I appreciate why you wouldn't want to use the fire hydrographic sort of approach to get the blue lines, but that is actually where the water goes. So that might be your best validation product for the casual user who just wants to see, is the tower leg actually where I know the tower leg is, because that's a huge confidence thing.
Yeah, I think with Mikhail's work and that sort of hydrography, maybe we can know the sort of things together. Yeah, what was Can you repeat your first bit of the question?
Yeah, what's to do with statistics for when you're saying, and I'm assuming you're using the LiDAR where you've got it from data.
Yeah.
And just give you an example of my challenge is when I use global statistics of work I've done on very dense LiDAR channels, but I've also had the opportunity to survey tens of hundreds of cross sections, you know, the processing algorithms often strip out information that you want to keep there, or they, you know, errors of omission.
Yeah, so we're not really looking at the channel footage, but the floodplain land is what we're looking at the LiDAR. And we've done a bit of stuff, but we kind of decided to get it out and let the community kind of come back and, you know, produce their own cases and whatnot. So, you know, we've had good feedback with finding these problems sort of thing, which has been really useful. And also, you know, we kind of come from the flooding world, and I've had people looking contact me about like solar panels and like health access and all this sort of thing, a huge range of things which I had no idea about. So I kind of wanted, you know, getting the different aspects of the community, and that's been really quite invaluable sort of thing. Thank you.
So great work. I mean, I've been using it and it's really much better than any other global freely available VM. But then I have a very important question. I don't know the answer to that, so I'm going to ask you here. But don't take it the wrong way. But when this VM is quite old, in the sense of the acquisition of the original. So when you use population data, and especially LiDAR data is very often more frequently required. So have you made sure that the date of your LiDAR pop data is the same?
Yeah. So we got like a broad range. So when we're selecting a LiDAR, so that's why it's not even more areas. So we kind of put it up to 2015. So a bit of context here. TandemX was acquired between 2011 and 2015. So that's affected the landscape we're modeling with, and also that they have a watermark product, so that's also the watermark from there. So when we're doing sort of all the predictive, we need to kind of make this sort of time scale, so we use travel time and all this sort of stuff as well. And I think this is really interesting for the flood modeling community, because if someone says, okay, I want to model South Sudan flooding now, actually you're using elevation data from 10 years ago if you're using FLTM 20 years ago. And the same with these different watermarks. They're kind of all the sort of time frames are not consistent. You know, eventually Google might release like a near real-time DEM or whatever. That's kind of like probably what will happen eventually. But you know, to date, this is the sort of best we can do there.
One last one, and then this is very quick. I'm just curious in terms of archiving and sustainability, and then obviously Google identity the platform. Is there support to like the archive, like you want to, or is it?
Well, where to put the data is pretty tricky. It's like a data for instance, is basically they're designed to put just like CSVs on there, not a massive 300 gig data set. So that's been quite tricky, and we were hoping to get it on open topography, but because of the like semi-commercial aspect of it, they understandably wouldn't host it. So yeah, we've kind of not really got to a good way with that yet. Watch the space. Because I agree, like archiving it and stuff is really, really important, and access and whatnot. And I would definitely say that's suboptimal now. I was just kind of hoping someone's going to get a nice GUI out there somewhere and do it for me. That was the but not yet.
Okay, I say we have to move on. We're a bit late, and you want to have your coffee now. So thanks again, Laurence.
Thank you.